The epoxide opening under acidic conditions is really more of a class of reactions rather than one specific set of reagents. Under acidic conditions, we can open an epoxide with water or really any non-bulky alcohol. We just can't use any good strong anionic nucleophiles under acidic conditions. This example is shown with sulfuric acid, but any generic strong acid would do. And as we'll see in the mechanism, we'll open the epoxide at the more substituted side of the epoxide. The first step in this mechanism is to protonate the methanol, or the water, or whatever small alcohol you're using. That forms the protonated alcohol, and we can transfer the acidic proton to the epoxide. That protonates the epoxide and activates it so a weak neutral nucleophile can attack. The next step is analogous to other bridged positively charged intermediates we've seen, such as a bridged bromonium ion in the halohydrogen formation, or a bridged mercurinium ion when we add mercury acetate. The nucleophile attacks the most substituted carbon of the epoxide, opening up the epoxide at that position. To open up the epoxide at the most substituted side, it has to attack from the opposite face, 180 degrees opposed from that wedged bond. That will invert the stereochemistry at that more substituted position while leaving the remaining OH on the original stereochemistry as it started, because that carbon did not get attacked. Finally, we'll use more of the nucleophile to deprotonate that protonated oxygen intermediate and make our final product. That forms an alcohol and an ether when our nucleophile is a small alcohol, or a diol when our nucleophile is water. The two oxygen groups are stereospecifically anti to each other in the final product. The opening of an epoxide under acidic conditions adds a weak neutral nucleophile to the more substituted side of the epoxide.